Hi, we're going to take a look at taking derivatives and integrals of bases other than e, and then we're going to take a look at an application of having different bases and e, especially when it comes to compound interest and continual interest. And we're going to take a look at these. Again, these are the notes for my class on the textbook of section 5.5, and we have this idea of we have some equation y equals 5 to the x, and how can we take the derivative of that? Well, the way I'm going to start out is I'm first going to show you the demonstration of where it comes from, and then I'm going to show you the shortcut. I'm going to use the idea that I can take the natural log of both sides. So over here I have the natural log of y, and I have x times the natural log of 5. So I'm using my logarithmic rules to be able to break this down a little bit. And what I'm going to do then is I'm going to take the derivative of both sides, and on this side, so I'm going to implicit differentiate, and I'm going to have 1 over y times dy dx. And over here I'm going to have the derivative. Well, this is just a constant times x, and if I took the derivative of 3x I would get 3. If I take the derivative of 2x I would get 2. Well, now I'm taking the derivative of the ln of 5 times x, and I simply get the ln of 5. And so if I multiply both sides by y, I get dy dx, I get the ln of 5 times y. Well, what is y? That is 5 to the x power, so I have dy dx equals the ln of 5 times 5 to the x. Alright, so that's the derivative of that, and if I take a look at some problems, I'm going to take a look at solving, and then I'm going to take a look at taking some derivatives and talk about how I'm using that. So the first example I have is not taking derivative, it's just solving for x. And so I'm going to take the natural log of both sides, and so I have the natural of 2 equals the natural log of 5. So x is equal to the natural log of 5 divided by the natural log of natural log of 2, and I'll let you use your calculator to be able to come up with a decimal equivalent for that. The next one is a log, which means it's base 10. The log of 3x equals the log base 10 log of 15, and since these logs are the same bases, I can say that 3x is equal to 15, which means x equals to 5. Problem number 3, I have the log of base 2 of x equals a negative 4. Well, this negative 4 is an exponent, and this 2 is the base, so I can write that as 2 to the negative 4 is equal to x. Well, that's 1 over 2 to the 4th, because the negative exponent means I have a fraction. And 1 over 2 to the 4th is the same as 1/16. So 1/16 is equal to x. Number 4, I have 3x plus 5 equals the log base 2 of 6. So that means what I have here is 2 to the 3x plus 5, I forgot my plus 5 here, is equal to 6. And so I'm going to take the natural log of both sides and have 3x plus 5 times the natural log of 2 equals the natural log of 6. So 3x plus 5 is equal to the natural log of 6 divided by the natural log of 2. I'm now going to figure out that decimal equivalent here. I'm going to do that on my calculator. delete this. The natural log of 6 divided by the natural log of 2 is approximately 2.585. So I have 3x plus 5 is 2.585. I believe that's what I had. That means 3x is approximately equal to a negative 2.415. And if I divide both sides by 3, I'll get a negative 0.805. And that's approximately what my answer is. Okay, I'm going to clear the screen. And I'm going to take a look at taking some derivatives now that I've done some log problems. And number 5 is y equals 7 to the x. And if you remember, dy dx in this case is going to be the natural log of 7 times 7 to the x. Number 6, I have y is equal to 2 to the 3x. So dy dx is going to equal the natural log of 2 times 2 to the 3x times the derivative of that particular function right there, which is 3. So I have dy dx is equal to 3 times the natural log of 2 times 2 to the 3x. This could be rewritten, and you might see this in another form, is this is really an exponent of 2, so I could say it's the natural log of 8 times 2 to the 3x. That is a possibility. Number 7, again I'm going to take y is equal to 3 to the x squared plus 1. So that means dy dx is equal to the natural log of 3 times 3 to the x squared plus 1 times the chain of that, which is 2x. So I think I could just leave that as my answer. Sometimes you see it written in this form. The natural log of 3 times 2x times 3 to the x squared plus 1. Number 8 is an interesting problem. And I have y is equal to the log base 7 of x. Well, I haven't, and I want to take the derivative, I haven't done that before, so what I'm going to do is I'm going to put it in a different form. I'm going to put it in exponential form, so that means my base is 7, my exponent is y, and my answer is x. And I'm going to take the derivative of both sides. This is going to be 1. This will be the natural log of 7 times 7 to the y times dy dx, because implicit differentiation means anytime I take the derivative of y, I'm going to be writing dy dx. So this is going to give me I'm going to divide both sides by the ln of 7 and 7y, so dy dx is going to equal 1 over the natural log of 7 times 7 to the y. But 7 to the y up here is the same as x, so I can rewrite my dy dx as 1 over the natural log of 7 times x. Now notice, here's my base, here's my answer. So the shortcut would be directly going to here. Now if you also notice, the derivative of x is 1, and we'll see how we approach that in our next problem. Alright, let me clear this. And so if you take a look, there's a general form that if I have the log with a base a of g of x, and that's equal to some y value, dy dx is going to be, first of all, it's going to be a rational expression. Down here is going to be the natural log of a, which is this base, times g of x, which is this function, times its derivative, g prime of x. So if I take a look at the next problem, number 9, I have y equals the log base 3 of x times the square root of x minus 7 over 2. Well, that's pretty complicated, so I'm going to use my log properties to break this apart a little bit. I have the log base 3 of x plus 1/2 the log base 3 of x minus 7 minus the log base 3 of 2. So when I take the derivative over here, I have dy dx is equal to, I'm going to have the natural log of 3 times x times its derivative, which is 1, plus 1/2 times the natural log of 3 times x minus 7 times its derivative, which is 1. The derivative of x minus 7 is 1. This is some type of constant. I don't know what it is, nor do I care, because when I take its derivative, I'm going to get 0. So my answers will look like this: 1 over the natural log of 3 times x plus 1 over 2 times the natural log of 3 times x minus 7. And that's my derivative. All right, I'm going to clear the screen and go to our next problem, which is number 10. And it says this: y equals the log of the cosine of x. Now, the base here is 10. We don't write the 10 in there, but we just need to know that because when we take the derivative, I'm going to have a rational expression. I'm going to have the natural log of 10 times the cosine of x. Its derivative is negative sine of x, and I can rewrite that as a negative tangent of x over the natural log of 10.